Hello, everybody. Welcome to Electric Vision Entertainment. We're all about tech, thoughts, and thick hair. I am your host, Aleia. I am your resident roboticist, technologist, chaos theorist, and general builder and creator of technological things. You've probably seen me, if you've seen me before along the internet, just sharing different things in technology, writing articles, maybe even doing a little poetry here and there. But on this show, we focus a little bit more on the robotic side. We work on building robots, learning about circuitry, soldering, Arduinos, electronics, all that fun stuff, as well as looking at the code for it. Oftentimes, I find that people look at code and they only see it as software. They only see it as apps or websites and crazy algorithms running around on the internet. But there's also embedded programming, which is more what we do here on the show, but just coding for robots, being able to get our code and talk to machines. There's all sorts of ways to do it. We're going to try different ways. So if it's your first time here, welcome back. Or, well, if it's your first time here, welcome. Make sure to subscribe to us on Twitch. And that way you can see us every Saturday, same time, same place. I believe it is at 2 p.m. right now. So yes, make sure you come every week. We're going to try different things. We are definitely a community here. You can join our Discord at make.sc/join-discord. And then that way you can talk to our community. It's not just the Make School students, as you see here through Make School. But it's not just the Make School students there. On the Discord, you can find people from all over the world, all over all sorts of age ranges, all sorts of diversity in that group. And we all are brought together by our love of technology and wanting to create new things and just have fun playing with tech. And if it's not your first time here, welcome back. I'm glad that you subscribed so that you came back here. And then just as well, of course, we have the Twitch channel here, but you can find us on YouTube and Facebook as well. So never fret. We're all over the internet. You can find us somewhere. And then for me, myself, of course, you can find me on my Instagram, which is Electric Empress. So it's electric_empress_. And then if you go there, you can find reels from this show. You can find updates about upcoming shows. You can see articles that I've written, or you can just reach out to me in general and say, hey, Leah, I really like your show. But maybe you can try this thing, or this, or hey, I saw this robot. It'd be really cool if you built that robot on your show. Maybe we will, because I feel like half the ideas I've gotten so far are from people who have watched the show. So I would really appreciate you guys reaching out to me, letting me know what type of stuff you want to build. Because while this is a show for me, while it is a show for me, and it's also a show for you, I want to use this as a way to, for one, just have fun playing around with robots. But then also to teach other people some of the things I know. Also, you can just learn with me because I don't know everything, so I'm only learning in the process. But say you want to learn about Raspberry Pi. I know that's a really popular kind of embedded system that people like to know about. You want to know about that? Let me know. And if I'm able to snag one of those, learn a bit about it, we can do it in the show and learn about it together. So that's the point of the show. So definitely, like I said, come back every week, see what else we have to check out, see what else we're going to work on. So what we did last week, just a recap real quick, previously on Electric Vision Entertainment, we did music. So, occasionally we'll do tutorial type of things where we're working step by step on how we're going to build something or how this process is set up, or just a skill to be learned. Other times we'll just work on projects. So last week was more of a project. We just did some music. We learned a little bit about how the pitches and the tones work with Arduino, how we can build even a piano with just basic parts, as well as we can code in certain notes, frequencies, and patterns to just create a song from scratch. And I'm considering something about that for you guys. Maybe another coding challenge, perhaps, in that regard. We will see in the future. We'll put some brains on it and see what comes out of that one. But this week on the show, what we're going to do is we've spoken several times in the past weeks about Arduinos, which again, it's this little chip here, little baby Arduinos. This is a Uno, of course. And it's probably the standard just because it has like a basis of everything you need when you get started. So that's the upside. So, you know, the downside is a couple of different things that I've noticed myself. And it's not anything to do with the hardware itself or the software. It's more so just human stuff. You have to buy them. Just the simple point of truth is you have to buy Arduinos. And while they're not like, you know, $500 each or anything crazy like that, they're maybe like $30 or something. At least for the Uno, they all do different ones, varying prices. But you know, when you're working on certain projects, like say the robot that I showed a few weeks ago, when you're working on things like that, the board has to stay with it. I'll put that over here so you can see. We have that on the screen as well. So when we work on robots like this guy, who's all ripped open into pieces, this baby here, as you see, he is missing his brain. You know, it's on his back. This Arduino was his brain, so it was sitting like here. It was mounted like on there like that. But when you build robots like this, they have to keep their brain. You can't just like put it all together, program the Arduino, and then take the Arduino off and think it's going to still work, because it's not. It still has to have that brain. Now, technically, this is the brain. Let me hold this. Not this exact chip, but the chip. Ooh, there we go. They look like this, look like little spiders. This is the brain for the integrated circuit, or IC. On this Arduino itself, it's this square piece. It's surface mounted, which is why it's smaller and square, just for like spacing and organization and stuff. But it's technically the same as this one, actually. These two are the exact same. They are called, the name of this particular chip is the ATmega 328. Now pull up the pin map because we're going to build it today. Or we're going to get as close as we can to building it today. We're going to do this in multiple steps. Since we've learned how to solder, a few other things, we are going to work on getting it on this breadboard. We're going to build it on a breadboard first. And then if it works, then we will move it from the breadboard to an actual proto board like this, or one like this that we were working on a few weeks ago. And do that. We probably won't do it to the point where you like order it and get it sent in and do all that crazy stuff, but we are going to work on just making it so you can make your own board. And I said that's the main reasoning to that, is because when you build these robots, I said you have to keep the brain with it. So every robot you build will require you to have another one of these. And while it's not horrible to constantly invest in having a bajillion of them, it will be nice to like practice your own skills, making your own, and then you can customize it. You know, when I buy this one, this Uno like this, it is what it is. What they send me is what they send me. I have to deal with it. Of course, I can wire up some things probably to get around some functionality, but overall, what I get is what I get. When I use my own circuit, when I use this one, I could perhaps put in a faster clock. I could put in different transistors, voltage regulators, capacitors. We probably won't edit too much in terms of the core functionality, but say I don't need all of these pins here along the side, or these pins over here along the side. Maybe I only need 4 for the robot, and I can cut the space used in half and go from having something this big to having something this big that does the same thing and just have it sit with that robot or sit on another project separately. So that's what we're going to aim to do today. I'll pull up the pin map because that's the more crucial part of this, is knowing what each of these pins on here, each of the legs per se. The most important thing is knowing what each one does. Inside here, it's a bunch of complex circuitry inside this little thing that we probably will never go into. And each of the legs is tied to certain ports, certain electrical lines, etc. So knowing which one is which is key. The same effect as these pins along the side here. The only difference is these on this IC, all these little lines are wired inside of the board to each of these. So it's the same thing, it's kind of just like blown up, expanded, so that you can easily put, plug in stuff here versus having to like attempt to I don't know if it's gonna work. Attempt to do something like this where it's like a female header on one side and try to plug this into here, and then it doesn't even fit, and then there's not going to be space to put a plug. It's just unnecessary. So if we can tie it down to something like a breadboard or something like this, where these connections are running through wires underneath or on the back end, and then you can have more ready access to it later and put in any components we need to in the interim. Because, for instance, say we need to tie one of these headers to power or to ground. You might be like, well, before it goes through that pin, we need it to go through a resistor. So we want to make sure we put, the header and then a resistor and then a wire to an empty spot to plug in our signals to. Hopefully that kind of makes sense. Do you have any questions in any chat before I continue? I know I just kind of info dumped everyone a little, which, try to keep the balance. Robotics is a lot, so definitely if I just like info dump you, or if I'm using too high terminology and I start rambling and it doesn't make sense, tell me and I'll go back over it, or I'll try to break it down a little bit more. Makes full sense. What's the smallest you can make a board? You can make a board. Well, I don't know. That is the literal question. Me myself, I probably wouldn't go smaller than this because I don't see myself. I think the smallest I personally built was about this size, and it was an Arduino that we're going to do. But that is the literal question of our age: is how can we make it smaller? As someone who works right now, I'm a senior technician at Intel, and that company is literally built upon the idea of how do we make boards smaller. That is literally the entire company, is making boards that are fast, same functionality, if not better functionality, that are smaller. And so that's when you get things like, to look on here, sometimes it's hard to tell which one is which, because some of these are like, I think this is an integrated circuit, I'm pretty sure. So like these little small piece, let me speed it up. Sorry, we got instruction. Let me turn that off. Haha. So like this one here, this little square, and then we have over this one right under the crystal. Here is an integrated circuit. These are all circuits, like fully functioning circuits. Now, mind you, they may not have the same full functionality that this whole board does. When it comes to the full functionality of a board, just looking at our Uno, this is the smallest one. This is the actual brain. Now, the other integrated circuits on here, they may control other smaller modules. It's like when we code and we had, we were working with our Arduino code. We had that setup function, right? We could have one integrated circuit that's just setup. Then we can have another one that's like a separate function that says, I don't know, that solely checks if power is on or off. And that's all it does. And then there's the main function, which is this circuit, which actually handles doing things in runtime and things like that. So this is the smallest I've seen. Well, not I've seen, but this is the smallest in terms of the Atmega 328 that I've seen thus far. I'm sure there's tons out there that are smaller. We probably won't handle anything smaller just because the smaller you get, the more space you have to be conscious of, which is why when we're doing through-hole soldering, we are using these type of circuits because they're just small enough to fit into the holes of the breadboard as well as through holes on our circuits like this. But if we were doing surface mounted, that's when we can start getting smaller, which is why industry standard is good to know through hole soldering, but you go for soldering certifications on a professional level, they usually want you to be able to do surface mounted because they do want you to be able to handle really small components because that's the future. It's the present and the future. It's smaller but faster. So, yes. But you can make it as small as you have the technology capable of. I don't have the technology to make one like this myself, but the technology exists. So let's see. Any other questions? If not, I'm going to start gathering some parts. I'm probably going to build this board on a white breadboard here. Now that the camera is better, now that we've leveled up, we have a better camera. And I don't think this circuit will take up too much space just from looking at the layouts that I have on my end. We should be able to do the whole thing on here. I'm going to use this one because it's prettier for some reason. It doesn't always want to be, but yeah. So what I'm going to do is I'm going to pull up for you guys how to find the pin sheet, which is very easy because we're running with our friend Google. Because he's our friend. I'm going to show you the pin mapping. So here is Google, and on the screen, I'm going to simply up Atmega 328, pin mapping, and then images, and you can just immediately see what we're looking for. So I usually will get this one. Let's look at this one real quick, just because it's laid out really nicely. Actually, yes, I like this one better. So let me try to jump in because I don't want to open. Ah. All right, that'll do. So this is our pin mapping. So what that basically is if I got the chip we're gonna use, and I'm gonna do an edit before. Well, I'll put it on there. We're not gonna actually activate it for reasons I'll explain a little later. But so it's important to know where each of these pins go. So here they go on the black by its actual name. So if you look at the official schematics for the Atmega 328P, I had to check that was the one I'm using. Because there's a 28P and 28 something. There's 328, 3 Atmega 328. So if you look at the actual schematic for it, it goes by these names, the PD and such. And so that's the name they have on here. But across from that, you'll see the more regular name, the more human-friendly name, we'll say. For instance, I know, if they just showed me these black names for it, BCC ground, I know what those are. AREF, I know it's probably analog reference ground, analog voltage here. But then when it gets to these, I'm I don't know what you're talking about. So we translate it here, we have reset as 1. These are our digital pins 0 and 1, which is receiving and transmitting for when we're doing serial input and output, which we haven't done too much. We did it vaguely when we did the ultrasonic sensor, but that's a whole different thing as well that maybe we'll go. And so on, PWM is pulse width modulation, which I think I talked about a little bit more. Is basically where a digital input can disguise as an analog. It kind of just scatters about the one, digital 1 or 0, and analog any number between that. And so with pulse width, it kind of scatters the digital signal so it can emulate looking like it's multiple. Yeah, we might go into that a little later. But basically the same flow of these are digital pins, these are analog, and it's laid out the same way as if it was on the Arduino. So that right there just tells us that we know where things approximately should go. So we're going to use that mostly as a reference. I also have some other references on other screens all about the place, but we're going to keep this one as our main, and then I'll build it and explain what I'm doing as we're going. Cool beans. So what I'm going to do, we'll go back to showing you my camera or my desk so you can see what I'm working on. So first thing I'm going to do, I realized that I don't think I had ordered. It wasn't until literally this morning as I was going through everything and looking at chips, and I was like, I don't think I ordered the correct integrated circuit, because all of them were like the ones I just showed you. These really small ones like this. And then it occurred to me that this is not a 328p. You can usually tell by looking on here. I don't think I'm able to even remotely get this, even with our magical zoom in abilities, because of the way that they write the text on here is almost impossible to see it. I'm tempted to pull it on my magnifying glass and put it under the camera, but I guarantee it's not good, because they kind of, you would think they would put the text in a different color, but it's literally like a brown that's almost the exact same shade as the circuit is. So hard to is what it is. So what we're going to do instead, we're going to make a workaround. On here, it is an Atmega 328. Because they don't surface mount this, and I guess they made it so that it's able to be removed, you can kind of see right here. Oh, let me scoop that. So you kind of see right here and then here. This is not the same product. So the top part is the actual IC, and it's kind of being held in this socket at the bottom, which technically I should have a socket for what we're about to do, but I don't. So we're just gonna plug the circuit straight into the board. It'll be fine. It's not as secure, but it will be fine. So we're not soldering it on there. Even if we do, we could technically solder the circuit straight to the board. I don't know why they decided to use this, but it works. So what we're gonna do, I'm gonna just take this out. When it comes to programming our Arduino that we're going to build on this board, because I don't have a proper setup that will allow us to plug in the cable, I will pre-program, if we have time to even finish building the whole thing today, I will take the chip off, install it back onto this whole unit, plug it in, program just a simple like LED blinking type thing, take it off of this board and plug it back into ours. And the reason that makes sense, or the reason that works, I know it may sound like weird, like, oh, you programmed it on this board, so it should work for this board. Technically, though, again, this board itself is just its body. It's like if you had a car and you took the engine out. Like the car, the rest of the car still like should technically work, but it's not going to because it doesn't have the engine. That's the crucial part. Then if we built a different car, say it's, a red instead of blue, but all the parts were still there in terms of functionality. Once I put the engine into the car, it should technically work. I know I'm stretching for an analogy, but I think it kind of works. If not, someone give me a better analogy. So, when I program, even if it's on this board, once I program this board or this chip, then I can take it off and put it on another one, and it should still have the same program. As we've seen before with Arduinos, even if I change the hardware setup, even if I unplug it and replug it back in, we are embedding the program into it. We are literally, it's like tattooing the program onto this. It doesn't go anywhere. forcibly put another thing there. So once it's programmed forever, 20, maybe 20 years later, it'll still be on. Or I could build a completely different robot, take off that one little IC, build this whole robot, take off this one little IC, and then suddenly it's gonna work. And put it on another one that should work. So I'm gonna go ahead and rip this off. Hopefully it comes off somewhat easily, because we'll see. And if not, I'll definitely just build the skeleton of what we need to do, and then we'll come back to this next week. I said this project will probably be done over multiple weeks on this show. Some of the projects here, not even some, most of the projects we've worked on so far on the show have been kind of one-off type things. We're like, all right, we're going to do it, or we're going to just, it is what it is. We're going to do it mostly for the purposes of seeing if we're able to make it. And then we're usually able to make it, and then we call it a day, right? But for this one, I want to make sure we can like fully cover making one from scratch, as well as on the breadboard, as well as on the proto board. So with that being the case, you know, this one might be a little bit more of a series where we're doing parts one week, parts another week, you know, to be continued, part one type of stuff. All right, so here we are. I'm so glad that it came out without ripping, because I was concerned. Here we are. It's a little longer than the other one that we had, but as I said, it has a lot more functionality than the other one as well. I'd have to look into what the other one does. Be mindful. Be mindful. There's documentation for everything. It is something I am more and more quickly learning is important. For myself, as someone who writes code, as well as someone who's working on machines or reading code, documentation is literally everything, because you're usually not the one building it. But the person who built it knows how it works, and they tell you how it works. Almost everything you need to know, they will tell you how to do it. And so be mindful. You can always, like I said, I pulled up just on Google a quick little image of it, but you can always go and look at the official, like, at Mega 328p documentation, and it'll go into depth about what's happening underneath, inside at the actual circuitry, what's going on with the actual pin, how they say you should set it up, according to what they think it should be used for, stuff like that. Make sure these are set up. So for this, first thing I'm going to do, I'm going to hop into this, and I'm like just chit-chatting, which is fine, because I'm going to make sure we have things set up. There's a general level of understanding of what we're aiming to get to, as well as, like I said, answering any questions people have in chat about this. And I'll try to write up. Like I said, I've worked on this project before, years ago, and at the time I was not good at documentation, so I have like almost no records. If you go on like my Instagram back sometime, then you'll see there's a robot on there that I built from scratch, and its board is a handmade Arduino board. So I've done this before, but at the time I was not a documentation writer. So there's no record of how I built it, and I don't remember. So I have to do like some hunting to figure it out. What I'm planning to do this time is to not only for this project put out some sort of documentation of like, hey, this is how you build an Arduino from scratch, and make like kind of a step-by-step tutorial later, once we get it working, but also to, like I said, I write articles on Medium. You can go on my Medium, and I'll probably put out an article about like, this is how you build an Arduino from scratch. So if you don't completely follow today or throughout this series, if you have more questions or just want to get more information and read it yourself, take your time to digest it. If you want to work on it yourself later at home, then those resources will be available. I'm not going to say when, because if I put a deadline to it, I can't promise we'll get that deadline. But it will be soon. So what we're going to do, so for our power source, I'm going to use a battery, a 9-volt battery. I did not get what I wanted to get for this, which was the one where, actually I do have one. I don't know where it went. I'm putting things on my desk. I apologize. Well, you can't see it at the moment, but I'm all over the place. So, I do have one of these type of battery holders that is stripped on the end. It doesn't have this plug. So again, this plug makes it so I can only plug it into an Arduino. And usually that would be fine if I had one of these adapters that wasn't mounted to a board, but I do not. I'm 99% sure I don't. 99%. Yeah, after just checking, I'm 100% sure. So what I'm going to do when it comes time to testing our power and ground, I will snip this piece off and just is what it is. Yes, it is what it is. And so, and then if I absolutely 100% need this again, I will solder it back and I'll show it to you guys on air. If I decide like, yes, we're going to use a 9-volt battery again, and I don't have another replacement by that point, I will just show on air how to solder 2 wires. Because I know I mentioned it on the soldering show and then I never did it. I just kind of explained how it was done due to time. So that's one thing. So what we're going to do is I'm going to go ahead and start setting up some of the lines for the power and the ground. So like I said, I'm not going to plug this in yet, just because we don't need it quite yet. We're not going to test anything with power today. Most likely we're going to keep this going throughout the next week. But as you know, as I've mentioned, we got these lines along the side. So when we utilize those to our advantage, they will be power and ground. I'm going to use red for power, blue for ground, or black for ground, depending if I have black wires. Probably don't. So probably be like gray or blue or brown. Something like that. We'll see. So what I'm going to do is going to get a red cable and black cable. And I'm going to tie these two together. And what this is doing, I'm just plugging this black cable from this blue line to this blue line, and then this red cable from this red line to this other red line. And all that's doing is connecting the 2 sides of power and ground to the whole board, so I can utilize either side. So this way I don't have to say, get this and extend it to like split this twice somehow. I'd have to like solder 2 separate wires if I wanted to use both sides of this board to get power over here and over here. Instead, tying both sides, I can plug this into just this side. It'll go down this whole strip, jump over here, go to this whole strip. So if I don't have space, say this half of the board for all my components, I can put it over here and not have to worry about trying to cross them onto this side. I can just say, hey, go over here instead. It's a little easier for wire management. So it just connects the whole board up together. And then I know, sorry, I know from my end that I'm going to have a voltage regulator, which really a voltage regulator is exactly what it sounds like. It regulates your voltage. Say I have, say I want 5 volts for sure, but I'm using this 9-volt battery. The voltage regulator can make sure that we're only getting 5 volts through. And then if we get bouncing, I don't think it's called bouncing in this case, it might be called bouncing. But say our signal's like just fluctuating a little bit, like we need exactly 5 volts, but for some reason we might get like between 6 volts and 4 volts. Then the voltage regulator is going to take that in and set it to 5. And then it has an output as well that it dumps stuff. So keeps your circuits and your parts from like blowing up, overpowering, or even underpowering. So I know I'm gonna need those in the future, so I'm going to just lay some lines out for them, and then you'll see a little bit later where they're going and why. I'm actually gonna flip this and do it at the bottom. The only reason I'm flipping it is because there's letters on here. And I kind of have, for where I'm looking, everything's mapped by the letters. I don't know if you can see them, vaguely see them up here. You kind of see the squiggles, but it's just A to J. And then there's numbers along the bottom, so it's easier to know like where things go. So I'm gonna put this one. These are gonna be our power and ground for our voltage regulator. So I'm just going to tie. We're gonna put C to F. If it wants to work. I really love these and really hate these so much because on the upside, they're really great with wire management. On the downside, they never want to go into their places. I'm just gonna throw 2 of these on here real quick. Like I said, these are just power and ground for our voltage regulator, which I'm not gonna put on there yet. I'm gonna just lay out a little bit of the wiring. Use another one too. And we'll see in a minute why I'm putting these here. If I can get them inserted. And like I said, feel free, don't hesitate to ask questions in the chat and we'll answer them. Because I know it's all over the place today. Alright. Insert. And then I need to put like some little file one of these days. You guys should definitely hit me with some recommendations as well that I can play in the background for the show. We don't want it to be purely quiet all the time, but we want a general vibe here. I kind of have a sense of my vibe, but also when I do robotics, I don't know why it is. I feel like I turn into a robot when I'm working on robotics, because all I do is listen to EDM music and house music and just like screeching sounds of robot music. So let's get this in there all the way. All right, this is our power and ground. And then I'm gonna tie it over here to the same thing, to power and ground on the other side. So need the longer pieces. And so this one I'm gonna put to power. It's not gonna connect to anything, so to make sure it's not touching anything, because we're getting our power. It's gonna go somewhere else. We're gonna set it a level lower. So that's there. So they see that beautiful, not beautifully laid, even though it was a struggle to get where I needed it to go, but it's definitely there. So we got that one. And then we're gonna do the same for ground. We're gonna connect the ground to, I can get it out. We're gonna connect ground to the ground for the transistor that is not here, but it's there in my mind. So and then see a question that came up, which is, does the colors mean anything? In this case, no. Usually the best practice is to try to have the colors coordinate. Because of spacing, mine are not always going to coordinate. So I said red and black, I almost always will try to exclusively leave for power and ground when it comes to stuff like this. Now I said these lines up here, this brown and blue, they are also power and ground, but because of not having short enough cabling that are like pre-made for those colors, because I'm using these this wonderful wire set here. They only come in the colors they come in. And so for whatever reason, the shorter ones are like these colors. So right now they don't need anything, and we just kind of have to, as we go forward, kind of trace it. Just like in coding, you trace through the code to find your error. It's the same here. I'm like, all right, I know power here goes here, then it doesn't go anywhere. Ground goes to this, then it jumps over here, and it goes to the yellow, which will jump up here. So that's kind of what we're doing. So right now, no particular color meaning. I probably won't do any color meanings for what we're building today, just because of, like I said, because of space. Really just because of space. If I had a full wire set, sometimes they sell wire sets that are like this big, and there's just like threads and threads of wiring on there in different colors. Then I would just snip my own wires and do it that way, but I don't have that at the moment. So I'll go with it. So now that we have that, what I'm going to do is add the voltage regulator. It's a 7805. I believe it's these guys. I have 2 packs of voltage regulators, so I have to make sure I have the right one. So these things. I believe these are. No, there's parts. There's only a lot of parts on this. So we have the capacitors, the regulators, the crystal, a couple other things. So this one. It's kind of like I said, it's going to be the same again, where you're not going to be able to read the text. It's just how they set these bad boys up. But this is a L7805, and it is a 5-volt regulator. So they come in handy. I've been using them often over the years, so this is probably the one I'm going to use more than anything. So, and we are going to plug this up. So our positives. Oh, just a quick explanation. This is positive right here. The middle is the ground. Let's scoot that back up. So the left pin, if it's facing you, left pin is power, middle is ground, and then the right side is output. So that's what we're going to set this up for. And make sure I have everything connected the right way. Middle is ground. Yeah. I'm probably gonna have to move these wiring. Probably go back and do some editing to this later today, or fix out some stuff before the next show. So we're just gonna put on a couple components today just to get a gist of it, and then I'll probably, like I said, between now and the next show, I'll actually put out documentation about this, like share some documentation. I'm not sure where I'm gonna put it yet, because you will let me know where you think would be the good place to put it. Well, I'll put it in the Discord for sure. I'm not sure where I'll put it in, which channel in our Discord we'll put it in. But like I said, I'll also put it out on my Instagram in some way, shape, or form. Probably I'll link it to the Discord. If you have like my Electric Empress page on Facebook, I'll put it on there. I'll probably, hopefully, have a full article written about it. And in that way, between now and the next show, we can kind of have a more in-depth understanding of what we're building. So when you come to the show, you can, like I said, have a better understanding of what's going on and how things are functioning. So then I got that laid out. I'm going to move some wires on here because they're not in the right place. But the general gist is this is going to be our regulator. When we did our Arduino before here, you'll notice that most of our power sources, or maybe not, you'll notice, but if you look at our Arduino a little close, you'll notice there are 5-volt. This is our base power. Excuse me. It takes in usually about 9 because it's just kind of the default. but most of the time it's going to be outputting at the 5 volts. So that's why we have this 5 volt regulator on. Plus, we don't want to burn out the board, considering some of the other components that are on here. Then we're going to add some capacitors. So our capacitors are 10 microfarads, which was this one. How do I hold this? Oh, it's trying so hard. I don't want to grab it that way. Yeah, something like that. Either way, this is our capacitor. There's different types of capacitors. As I mentioned before, there's like small ones. We'll also be using those. These ones just can handle a higher load. These other small ones, these little baby ones here, I have 2 of them, by the way. They don't handle as much. But the capacitor basically just takes in like excess. So how I was saying before, that the voltage regulator can take in, say, 9 volts. Let's say we want to output 5 volts. Well, what happens to the rest? It's going to go through this capacitor usually. And the capacitors, I don't want to say it's like a battery, but it kind of, it's not a battery. It's like, think of like a retard, or think of a rechargeable battery. It puts out voltage, but it also stores voltage. That's kind of what a capacitor is, where it's going to pull, current is going to go through it, and it's going to store it and keep storing it. And then once it gets to capacity, it kind of just holds it and keeps it charged. And then as needed, it drains out. So it kind of also is a way to regulate it, so it's not just like constantly dumping it out super high all the time. It's kind of slowly trickling out while it's filling this up. And that's what happens to some of the excess. Some will probably go through the capacitor, others are going to go through ground. I'm going to go ahead and add that on here. I don't believe, yeah, there's an input and an output on this. So we're going to put this between our input power and our ground. This is why I don't plug up anything. I'm not sure which side is negative. This is our negative side. So we want to make sure our negative side is going to ground, which is the center pin. If you can kind of look, said some of the wiring isn't where it needs to be, but you can see that like on our positive side, it's going to our input power, just the left, and then our negative is going to ground, which is the center. And you just know that it's connected just because, like I said again, each of these horizontal numbers, like each 5, well, not in this case 5, this 5 on this side is going to go across. So all of these are 5, 10, 11, etc. going across or connected. So with this being, kind of hard to tell, but as long as I make sure that these pins are in the same row, then they're all connected to each other. Yeah, and so just wire management. So we have that there. Are we need any other capacitors? I think that's it. Might need to do one more, but yeah, we need one more. So we're gonna do one more as well. This is gonna be between our output voltage and our ground. So the same thing, but instead it's gonna go from output, which is our very last one on our right. Well, the one closest to me, to our ground. So make sure the negative side is going to go to ground. So instead of putting it on this side, we'll put it over here just because space. So we'll put it from output, and then we'll connect it straight to ground in this case. Boom, just like this. Yeah. So we got one leg over here, going to output, and then that's going to ground. So that's where our dump is. It's dumping it, like I was saying before, where once it goes through and it sets it, let's say we have extra 4 volts, It's going to go through into this capacitor. It's going to be filling up this capacitor, slowly trickling out into ground. So that's how we're dumping things. So that's kind of our like power management system for our Arduino. Let's see what we got on time. We just get a couple more components and then we'll work on some other things next week. I said this will be, I'm estimating 3 weeks. The soldering, once I know it works on the breadboard, that's the harder part, is getting everything set up on here and make sure it works. Then transferring it to the breadboard isn't as hard as long as our proto board is laid out the way we need it to, which for this one should be fine. We'll probably use this one most likely. Most likely. So, but transferring it and soldering it on doesn't take as long as like actually the original build. So at that point, it's just as long as you know how to solder and you put your pieces in the right place, should be pretty straightforward. A couple minutes. So then next we're gonna put a LED on here, and this is gonna be the same as this LED on our board, which is somewhere around up here. It's very small. Because it's surface mounted, so I can't tell where it is. But basically, it's kind of our like reset LED, so we know that it's working. Just like when we usually plug in the Arduino, there's that LED that always comes on to let it know it's working. That's what this blackboard is going to be. So we're going to do that real quick. Make sure everything still looks Gucci in the chat, which it does. So we'll put it over here, and I guess we'll use green. Yeah, we'll use green because why not? So we're going to go put a wire first off from our negative side to our ground, or the negative side of our LED to ground. I'm just going to plug in the LED anywhere right now. Just throw it on there. So we want from our negative side to ground, and then our positive side through resistor to the positive side. Just like we did with all the other LED builds that we were working on. Ground, the power is going to come in through the resistor into the LED and then out through ground. So I want to make sure I got my positive and negative sides right. All right. The negative side to ground. And what I'll also do next week, let's see if I can find the schematic for this. I think I had it. I might try to pull it up real quick before in the show today if I can find the link. But it's a schematic that I built for this a little while ago, and I can go over it real quickly. Actually, I'll do that when I plug this LED in, get it all situated. Then I'll pull it up so you can all see kind of a setup of how this is going to be, kind of what I'm referencing as well. It's on a different computer, which is why I haven't pulled it up, but I could probably get it on this one and share it with you all real quickly before we end today. So I got the ground, and then like I said, we're going to need a resistor. There we go. All right, I'm going to get a 220. You'll probably use a little less, probably like 200, 180. I stick with 220 because I have a bunch of them, and that's still kind of like my standard. So I'm going to go and do this resistor to power. It's a little simple, like, I know it's like somewhat hard to see because my hands are everywhere, but like, I can't only do so much with the tweezers. So this is where we're at right now. This with my tweezers. All right. So you can kind of see, let's scoot this back. We have our resistor going straight from power. It's going to go through a resistor here. It's going to go across to the LED. It's going to go through the LED, turn it on, turn it off. And then when it's leaving out, it's going to go out through this wire to our ground. So I'll probably plug it in over here. Cool, that kind of makes sense a little bit. So, are we on time? I'm gonna put the circuit on it, but I'm not gonna start wiring up the integrated circuit just because that's gonna take a little while as well. The upside is now that I've gone over a lot of the like instructional base stuff, verbiage, we'll say, in terms of how this is going to be set up and what we're trying to accomplish here. The next show, we don't have to do all of this. I would just pull up the schematic, give you know, a quick little intro to the show as we always do, and then I'll hop straight into it. So we should definitely be able to finish the board layout end of next week, have it be fully functional coding wise, and actually use this instead of this on the show. And that's something we might just do going forward because I don't think we'll do any more work with this Arduino in the moment, at least for another few weeks. I want to focus on us creating this Arduino as well as the full proto board one that functions. And once we get that, that would probably be our base. Like, we're not going to use this one anymore because I'll probably put this just back on that other robot and work on that robot in the future. But I want to make sure we fully can get to a point where we can have our own that we're using from now on. So just real quick, I said we're going to go over this and I'll pull up the schematics so you can see kind of where we're at, what we're doing. Here, the important thing to note is orientation. Just like with maybe a handful of the parts, you know, resistors don't matter. Those little capacitors I showed you, these little babies, so small ones, their orientation doesn't matter. A few other things, doesn't matter which way you put it. But when it comes to integrated circuits, LEDs, these type of capacitors, what they're called, they have a specific name. Transistors, things like that, they have orientation. So, and that's just how you know which ones are which. So here, there's a little notch. It's kind of hard to see. It's very hard to see. There's just the smallest little notch here on the top. And there it is. Kind of see it there. Doesn't do anything. It's just a marker. Where I work, when we do things with like sockets and circuits and things like that, we just refer to everything by pin 1. That's the important. If you know where the first pin is, you can find everything else. So this notch lets you know the orientation. And from there, you can find your pin 1, which should be this one. So corner machine. And then once you find pin 1, you kind of go like, oh, well, 1, 2, 3, 4, and then go around in a circle. So that's just something to note when you're putting on circuits, making sure you know which way the notch is facing so you know which side is pin 1. So yeah. And then again, as I said before, usually you would use a socket for this. It is kind of the standard in industry, definitely in industry, if you're doing mounted parts like this, is to use a socket, which is this piece here that I ripped it off of. It's just like a little thing so that you can solder the socket rather than the board. So if I was, you know, I mentioned before about heat damage. If I solder this onto the board without using one of these, then I'm putting heat directly on these pins. And if I'm not careful, the heat will transfer up into the chip and burn the chip out. So usually they want you to use a socket so that the socket can take off the damage because it's not doing anything except making and like a heat sink in a sense. So I'm going to just go ahead and drop this circuit on here because I don't have it I'll see if I can get one by next week. Should be able to get one by next week, even though my electronics store closed. But Amazon got my back, so it's fine. So I'm just going to throw it on here. Make sure it's seated all the way. You can see it's nice and smooth. Look at that. Buyout. It's already looking so pretty. Mostly, it's a little junky up here with these wires. I'll fix that later. So you can see it is seated in there pretty nicely, right? Yeah, that's the good stuff. Yeah, so that's where we are. I think that might be. I'm gonna slow it down. Don't add too much more. we're about halfway. About halfway there. I do want to do a little housekeeping, as they say, before we move too much further with this. But the gist is, going forward, now that we have, this is our main like power module to say. This is going to handle all power and just like reset. We're probably going to throw like a button up here for reset to die to this LED. But for the most part, the next few things that we need to add is like a crystal so that it can take a time. That makes sense. So it can read time. So it can like keep track of time. It's like it's gonna be like megahertz. So you need like crystal. You need like buttons, and then we might have like one more like power piece to add on. But then after that, I think that's it for the most part. So let me see really quickly if I can pull up for you all. I'm not gonna share that yet because I gotta go through some things to get there. But let's see if I can pull up real quick the schematic. We can go over that just like real quick. That's it again. Got any questions? Put it out there in chat, and I will answer them as quickly as I can. Well, I pull this up for you all. All right, let me share this. Okay, make sure that that's up so you all can see the circuit. So this is basically what we're building. It's laid out a bit differently because at the time, I don't think I was able to access the exact layout of the board that we're using. So it gave me the Mega instead of the Uno. So this is the 328. I don't think. I think this is a slightly different number. Integrated circuit, not a Mega P. But you can see like some of the components we've already built. Like down here in the right corner, we have this LED connected to a resistor connected to ground. So that's the piece we just built a little bit ago. What else? Where's our transistor? Ground. These are our pins, capacitors, diode, capacitor, switch. I think we have the transistor on here. Just looking at it, like I'm not gonna go too in depth into how this is set up, but like this here is a switch, and that's what the S is for. S1. You can kind of, in a sense, see that as a switch. You have one side. You this almost button-looking shape. You turn your head, and then this, where it's like if you put pressure, it will send this diagonal line to contact that, just like a button. Resistor. These are capacitors. This is a diode. Different diode, if I'm not mistaken. Q is a crystal. This is our crystal. We haven't added our crystal on here yet. So we'll add that next week. We'll talk more about what it is, how it works. Yeah, so let's see. Any other questions for me before we start wrapping up further? Well, with that being said, I'm gonna wrap today up because don't want to overwhelm everyone at once with a bunch of components. I'm gonna let it a little time sink in, and in this way, I can give you a quick introduction of what we're gonna do, and then I can provide a little bit more resources in other areas later on throughout the week, so that you can look into that, see some resources on the Mega chip, the general layout of these boards, some of the components. I said the crystal and the transistor that we touched on, but haven't went too in depth on, things like that. And so, yes, I'll put those resources out on our Discord once again at make.sc/join-discord. So, and that should still be all the chats across all the platforms. So you're able to go scroll up just a little bit. You'll find that there. I'll put those resources out. Like I said again, you can follow me. My media sources, which is like Electric Empress on Facebook, Electric_Empress_ on Instagram, or my Medium, which is like Aleia-Knight at medium.com. And I'll put all those resources there. Like I said, feel free to reach out to me to get more detail about like what we're doing here, recommend parts for me, recommend robots for me. I'm even, as I mentioned in the past, working on, I'm gonna do a robotic arm. I'm gonna need a 3D printer to build the skin. Recommend 3D printers to me. I know you guys have them. So I know you do, because I know everyone has a 3D printer, but so recommend 3D printers to me so I can invest. And we could do even more cool robot stuff, or just send me robot videos on like Instagram or something like that. But overall, that's what we're going to do for our show today. I want to thank you again for coming, spending this time like just playing around, goofing around with little different parts. We'll add some funky jazz in the background one of these days. Just genuinely having fun. Again, if you haven't been here before, hopefully you enjoyed the show and you come back. Definitely, whether it's your first time, whether it's the show like 14, 13, whether it's like your bajillionth time coming here, then definitely keep coming back. Share it out to your friends or engineers, or robotic tech nerds, or just in general. Like I said, we're here just having fun, learning about different robotic stuff. You never really know if you like it until you come and actually see it. So share it out to people and help build a community here on our Twitch, on Discord, and just in general. Have fun. So with that being said, I want to wish you all a wonderful rest of your Saturday. Hopefully you get some rest, get some sunshine. If it's sunny, get some hydration if it's rainy outside. And overall, I'll see you all next week. Enjoy the rest of your evening. Bye-bye.